Hi friends, welcome back. Today we are going to solve AtCoder Beginner Context 118 problem Monsters Battle Royale. Before we start looking into this problem statement, some examples related to the problem and the Java solution, I want to mention that my channel is dedicated to help people in their Java and coding interviews. On my channel you will find lots of helpful videos that can help your Java preparation and in your coding interview preparation. On my channel you will find over 300 different varieties of solved coding problems that can help you in your coding interview preparation, because those problems are constituting very vast varieties of coding questions that usually appear in online as well as in-person coding questions. That includes BFS, DFS, graph problems, binary search tree problems, problems related to linked list strings, optimization problems using priority queues, and lots of other logical questions that can be solved using different data structures such as set, map, queues, stacks. So if you are preparing for Java interviews or coding interviews, then this channel can definitely be helpful in your preparation. So please subscribe to the channel now. So let's first go through the Monsters Battle Royale problem statement. So there are n monsters numbered 1 to n. Initially, health of a monster is AI. Below, a monster with at least one health is called alive. Until there is only one alive monster, the following is repeated. A random alive monster attacks another random alive monster. As a result, the health of the monster attacked is reduced by amount equal to current health of monster attacking. So find minimal possible final health of last monster alive. So this is the problem statement. N is between 2 and 10 raised to 5 inclusive, and AI, which is the health of a monster, is between 1 to 10 raised to 9 inclusive, right? So there are some examples given. So let's take this first example on a whiteboard, then we will discuss some examples and the approach to solve this problem. So as you can see, this is the given input, right? So there are four monsters, their health is 2, 10, 8 and 40, right? So let's just write down this one here. So first we will just solve this problem, and then we will decide how we can formulate the approach to solve this problem programmatically, right? So let's just first understand this problem. So if let's say we have this monster with health 2, right? So any monster can attack any other monster they have given. So if this monster start attacking this monster with health 10, its health will degrade by 2, right? So it will become 8. If it against attack, then it will become 6. If it against attacks, it will become 4. If it against attack this monster, its health will become 2, right? So now both has 2. If this 2 again attacks this 2, it health will become 0, right? Once it health becomes 0 or less than 0, then he is not alive basically, right? He is dead. So after that, again let's say this monster 2 now start attacking monster 8, right? So same thing, like it will again go decreasing by 2. So it will goes like decreasing by 2, say 6, then 4, then 2, right? And then 0, correct? So similarly, he can attack afterwards to monster 40, right? And he can keep attacking this monster 40 again and again until its health becomes 0, correct? So if that happens, then 2 is the minimum, like 2 is the one last monster which is still alive. Now all other monsters are dead, right? And this strength is 2, right? So we have to output this strength in our output, right? So this is the minimum that can happen, right? We have to find minimum, right? So why it is minimum? Because if otherwise, if let's say for example, if 10 start attacking 2, right, then 2 will die, but 10 is the more strength than 2, right? 10 will be alive, then he can attack on 8, then he can attack on 40, but 10 is actually will be alive, right? So at the end, so we don't want to find out a monster which will be alive with more strength, right? We want to find out minimum strength. So because as you can see here, they have said that we have to find out minimal possible final health of a last monster alive, right? So in this case the 2 is the answer. So let's just consider one simple example, and then we'll understand more like how we can solve this problem programmatically. So there are three monsters here, 2, 3, 4 is their strength, right? So if now 2 starts attacking the monster with health 4, then what happens is its health will decrease by 2, so it will become 2, right? Because it will decrease by 2, the health is decreased by the amount of health of the attacking monster which is attacking, right? So it becomes minus 2, which is 2. Again 2 minus 2, it will be 0. So this guy is basically, this monster is dead once it becomes 0. Now there are two remaining monsters, 2 and 3, right? So if there are two possibilities here, right? 2 can attack 3 or 3 can attack 2. So if, right, because 2 and 3 are now two left monsters, this 4 monster is dead, let's say, right? So now the possibility of 3 is attacking 2, right? If this happens, then the 2 monster 2 strength will be decreased by 3, so it will become minus 1, so this is dead, right? So last monster strength will be 3 in this case, right? So this is one possibility. So let's write down 3 here. Now vice versa, if 2 attacks 3, right, its strength will go to 1. Again 2 attacks 1, its strength become minus 1, right? 1 minus 2, so he become dead. Now 2 is the last alive monster, right? So first, in the first approach, like first choice 3 was the case, now it is 2 is the case, right? So we have to find out minimum, so we will choose 3, basically we will choose 2, right? Because 2 is smaller than 3. So this is the problem. Basically we have to find out a monster which will be the last monster with minimum health, right? Minimum health. So 2 is the minimum health in this kind of case, basically, right? So how we can solve this problem programmatically, right? So let me remove this so I can explain you again with this example. So now as you can see, what we are trying to do is from this example itself, let's consider that there are 2 and 3, these two monsters are there, right? We want to find out minimum between them. So what we are trying to do actually, so 2 and 3 actually is let's just again, let me explain you again this one. So 2 and 3 when they are alive, then if 3 attacks 2, right, then he is the then its strength will go by decrease by 3, so it will become minus 1, so 2 will be dead and 3 is the last monster which is alive, right? Otherwise if 2 attacks 3, right, then the strength of the monster will decrease by 2 here, right? So it will become 1 again. Now 2 and 1 is there, right? 2 and 1 is there. So if now 2 and 1 is remaining, right, because 3 became 1 now. So now in this case 2 and 1 is there. So now again we have to find out minimum in 2 and 1. So which is the minimum, right? So if 2 attacks 1, then 1 will become minus 1, right? So 2 will be the last monster which is alive, right? So in this case 2 will be the last monster which is alive. If 1 starts attacking 2, right, then it will become 1 1, and again 1 will attack 1, it will become 0 here, right? So in this case 1 is the last strength of the smallest attacking monster, right? So in this case 1 will be the answer basically, right? 1 will be the answer because we have to find out minimum strength of the last attacking monster, right? So 1 will be the case. So you got the point, right? 2 and 3 started, let's say instead of 3 there are only 2 monsters. For the clarification, let's understand this, that there are only 2 monster, 2 and 3, there is no monster 4 here. Let's just take this case, right? So when 2 and 3 are there, when 2 attacks 3, then its strength will decrease by 2, so it will become 1, right? So in that case the monsters will be now 2 and 1, right? 2 and 1. So now again we have to find out minimum, right? If 2 attacks 1, then minimum will be 2, but that's not minimum actually, correct? Because if 1 attacks 2, then the strength of 2 will become 1, and if again 1 attacks this 1 strength monster, then its strength will become 0, correct? And in that case 1 is the last monster which is alive, correct? So this is the minimum strength. So I think you got the problem now, right? So what we are trying to do here in this explanation is basically we are trying to use GCD, right? Greatest common divisor of 2 and 3, right? So that is what we are trying to do, correct? To find out the minimum strength monster, which is the last alive monster, right? So this process, what we are doing here, this process is basically finding GCD of 2 and 3, right? So GCD of 2 and 3 is greatest common divisor, which is 1, correct? Which is 1. So that's why 1 is the answer here. If there are two monsters, 2 and 3. What if there are two, let's take another case where there are two other monsters. Let's say in this case 2 and 4 are the monsters. So in this case we have to find out the minimum. So minimum will be if this 2 attacks 4, it will become 2 comma 2, right? Again this 2 attacks 2, then this one will become 0 and this monster will become 2. So 2 is the minimum monster, right? So how we find it? Basically this is basically GCD of 2 comma 4, right? GCD of 2 comma 4. We are trying to find out the greatest common divisor, and greatest common divisor in 2 and 4 is 2, right? So this is what the logic we are going to use to solve this problem. So for example, let's we just discussed this example where we find out the answer is 2, right? So visually we find out. So how our algorithm will solve it? It will take first 2 and 10, let's say, right? Um, so GCD of 2 and 10 is 2, right? GCD of 2 and 10 is 2. So again we will take this 2 and 10 GCD with 8. So GCD of 2 and 8, correct? GCD of 2 and 8 is equal to again 2, correct? Now again we have 40 remaining. So GCD of this answer 2 with 40, if we do, then again we will get the GCD is equal to 2, right? So 2 is the answer basically using the GCD approach, right? So we will keep getting the GCD of these pairs, right? So like first 2 and 10, whatever answer we get, we will again do the GCD with 8. Whatever answer we get, again we will do the GCD with 40, right? So we'll keep doing it in loop, and then it will give us the final answer basically, right? So this is the approach we are going to solve. This is another example they have given us. So in this case, if you take the GCD of 2 comma 3, the GCD is 1, right? Then we will take GCD of 1 comma 4. So GCD of 1 comma 4 is equal to 1, right? Then we will take GCD of 1 comma 7, right? Then GCD of 1 comma 7 is equal to 1. So 1 is the answer basically, right? Because that is the minimum possible monster strength, which is the last monster alive, right? And why it will work? So let's just go through this example quickly. So first is if 2 and 3 are there are two monsters, we will take 2 and 3. If 2 attacks 3, right, then this 3 will become 1, right? Its strength will decrease, it will become 1. Now this is 2. Again now if 1 attacks this 2, its strength will become 1. Then 1 and 1 is there. Again if 1 this attacks 1, this strength is becoming 0 and this is 1, right? So this is the minimum strength monster now, 1. If we take like 1 and 4 afterwards, again 1 is the minimum strength monster, correct? Then 4, it can kill 4, and again if we take 1 with 7, it can kill 7, right? How it can kill 7? It will keep attacking 7 basically until it becomes 0, correct? Then it will be killed. But the minimum strength monster which is left at the end will be 1, right? So that's how the GCD approach works. So let's take a look into the Java solution for this monsters battle royale problem. So this is the input. These are the strengths of the monsters which is given to us. We'll just create one answer variable to 0. We will go through the all the this strengths of the monsters, right? And we will first start with a 0, and we will take the GCD of 0 and 2, then GCD will be 2, then we will take GCD of 2 and 10, which will be 2, After then we will take GCD of 2 and 8, which will be 2, and we will take GCD of 2 and 40, which will be 2, right? So 2 will be the answer, right, in this case. So we have just like lastly we'll print the answer here. So we are doing it like the GCD as I explained you in this example. In this example, I just explained you how we are going to take GCD. So we'll take GCD, then 2 of 3, 2 and 3 GCD is 1, then 1 and 4 GCD is 1, then whatever is answer of this GCD we will again take here with 7, right? 1 and 7 is again 1. So that is the approach of solving this problem. We have implemented one small helper function for GCD, calculating GCD of int a and b. So this one is a function you can understand. If b is 0, then we will just return a, otherwise we will recursively call GCD of b comma a mod b, right? So this is a recursive GCD function. It will give us the GCD of two numbers, greatest common divisor. So this is the simple solution for this problem. So let's execute this code snippet and make sure it works. So it is giving us answer 2 for this scenario. This is the first example that we took, this one, right? This is the first example. So we are getting correct answer. Let us take the another scenario, this one, where we will update our input. So again, let's just modify our input to this another test case. So these are the four monster strengths. Now as you can see, the GCD will be 1 here, right? GCD will be 1, so answer is 1, right? So let's execute this snippet and make sure this gives us, so it is giving us correct answer 1, as you can see, because the greatest common divisor is 1 basically, right? So let's take another input, this last input. So this is itself is the GCD. So as you can see, that is the answer. So we'll just make sure that this also works. So these are the just three monsters here. So this is giving us correct answer. So with the help of GCD, we can solve this problem as I explained you with these examples. So if you are new to my channel, there is a dedicated AtCoder playlist which has couple of AtCoder solved problems explained with whiteboarding session, examples and Java code. Apart from that, there are three other very important coding questions playlist. The names of the playlist are Leetcode and Leetcode solutions, Code Forces and Code Chef. So all in all, this playlist has over 300 solved very important coding questions varieties that are frequently asked by big tech companies like Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big tech companies. And those are selective problems to cover wide range of coding interview questions that appear in online and in-person coding tests and whiteboarding sessions. Those varieties include BFS, DFS, matrix problems, graph problems, problems related to binary search tree, coding questions related to linked list strings optimization problems, and a lot of logical questions that can be solved with different data structures using Java. So if you like this video and if you find this video helpful in understanding the problem better and solving this problem better, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve coding problems using logic and maths, so they can also watch these videos and understand how to approach different varieties of coding problems and how to solve those problems using different data structures using Java, such as linked list, strings, sets, maps, queues, tags. So they can also practice these problems, because the main goal of the channel is to help as many people as possible in their Java and coding interview preparation. So if you find this video helpful and if you like the way it's been created with whiteboarding session examples for easier understanding, please give it a like. Also put in the comments how this video helped you in understanding the problem better. So it also gives the encouragement to create better and better videos, more videos for you. Also share this content with your friends and colleagues who might get benefited by looking into these videos if they are preparing for Java interviews. And thanks for watching this video.